In today's video, we will be seeing about the molecularity of the reaction in chemical kinetics. It is a property of the reaction. Molecularity means the number of the reacting species, that is atoms, ions and molecules, taking part in an element. How many number of reacting species are taking part in an elementary reaction, which must collide simultaneously in order to bring about the chemical reaction. To bring a chemical reaction, number of reacting species taking part in the elementary reaction must collide. This is called as molecularity. How much number of reacting species are there is known as molecularity. When only one molecular species are involved, it is called unimolecular. Example, decomposition of ammonium nitrate. Ammonium nitrate decomposition is unimolecular. Here, this is ammonium nitrate, NH4NO2 decomposed to form N2 and 2H2O. This is unimolecular, only one molecule. Next, if we see, bimolecular reaction involves simultaneous collision between two species. Example, dissociation of hydrogen iodide. HI decomposed to form H2 and I2. Trimolecular or tetramolecular reactions involve simultaneous collision between three reacting species, like 2NO plus O2 gives 2NO2. Probability that more than 3 molecules can collide and react simultaneously is very small. Hence, reaction with the molecularity 3 is very rare. This trimolecular one is very rare and it is very slow to proceed. It is therefore evident that the complex reaction involving more than 3 molecules of stoichiometric equation must take place in more than one step. That is, it cannot be elementary, it can be only complex. So, here, if we see this much big equation, KClO3 plus 6FeSO4 plus 3H2SO4 gives KCl plus 3FeSO4 thrice plus 3H2O. It actually seems to be like 10th order, right? But it is actually second order reaction. This shows that the reaction takes place in several steps. Which step controls the rate of the overall reaction? Can be answered by seeing the relay race and all. The slowest person only will determine the win. Correct? Similarly, in reaction also, the rate will be determined by the step which is very much slowest. So here, if we consider decomposition of the hydrogen peroxide, which is catalyzed by the iodide ion, and in alkaline medium, it will form H2 and O2. The rate equation of the reaction is found to be like this: minus d H2O2 by dt. Reactant will give K H2O2 I minus, which is the catalyst. This reaction is the first order with respect to both H2O2 and I minus. Evidence suggests that it takes place in two steps. This is first order. Order is 1, but molecularity is 2, which is bimolecular. So H2O2 plus I minus gives H2O plus IO, first step. Second step is H2O2 plus IO gives H2O plus I minus plus O2. Both these steps are bimolecular elementary reaction. Species are intermediate. Species of IO is there, no? IO is intermediate.